Good morning, and thank you for attending the 17th Annual Cybersecurity and Awareness Fair. This presentation is about SCADA and cybersecurity in the water sector. For today's agenda, I would like to give a brief introduction about myself and Irvine Ranch Water District. What is operational technology, SCADA, and PLC system? The differences and similarities between OT and IT, the challenges and opportunity of mixing IT and OT together, or in another word, the convergence of the two technologies. Then I will share with you some of the recent cybersecurity events in the water sector and its potential impact on the public safety and disruption to the economy. Finally, if you stay till the end of the presentation, I will show you how to make a hacker cry. And if you have any question, I would be more than happy to answer at the end of the presentation, or you can send it to the chat as well. My name is Joe. I'm the Automation Manager at IRWD. That is in charge of the operational technology, which includes cybersecurity. My number one goal is to make sure when you open the water faucet, there is safe drinking water. When you want to flush the toilet, there's water available. And that is accomplished by working together with our operation team and keeping the SCADA running all the time so that they can monitor and deliver the water to you. Downtime is not acceptable. One of my passions is to automate everything so that I can reduce the tedious work and improve efficiency. I guess I found myself in the right industry, automation. Technology only exists because it makes our life more convenient and reduce the cost by increasing efficiency. My goal is to introduce technology to the automation team to optimize it, to make it more efficient, and maintain safe water quality while challenging our staff to take it to the next level. For education, I have a bachelor and master in engineering, but if you also notice, I stated YouTube, Google, and continuing education because in the cybersecurity sector, nothing is static. Someone comes up with a software that is supposed to protect you, and the next thing you know is that the software itself gets compromised. For example, SolarWinds, Microsoft, and even cybersecurity firms such as FireEye got hacked. Due to this constant battle between the security provider and the hacker, new software protocol and technology will be created, so you will have to stay current. You will need to have an open and growth mindset to change and continue to learn. The only thing that's permanent in life, my friend, is change. Learning doesn't stop the day you graduate. You might get a few days of break here and there, go relax, have some fun, go out for a party, but you will have to start learning again if you want to advance in your career life. You might wonder why I'm not showing a picture of water, but showing a picture of soil. That's actually fertilizer. So what does a water utility company have to do with fertilizer? The answer is resource recovery. We try to recover resources at every step. For example, we deliver drinking water to our customer. They use the water, do their things, flush the toilet, we collect the wastewater from them, and treat it through our recycling treatment plant. Send it back as recycled water for irrigation. Then we take all the thickened sludge from the recycling treatment plant and send it to our biosolid treatment plant. In that process of converting sludge into fertilizer pellets, methane is generated, and we are happy to take the methane and convert it into electricity so that we can use it at our treatment plant. As you can see, every step along the way, whenever we have the opportunity to capture the resources, to reuse it, we will do it. Our service area is roughly about 20% of Orange County, and we serve 5 cities: Irvine, Lake Forest, and part of Newport Beach, Orange, Costa Mesa, and unincorporated area of Orange County. Most of you have seen the purple sign that says do not drink recycled water. But have you ever wondered why the color purple? It started at IRWD in 1980s. Let's say you have 2 pipes. One is recycled water and the other is drinking water. You need to be able to tell which one is which so that you can tap into the right pipe. Otherwise, you might end up drinking recycled water. IRWD looked for ways to tell the difference. The head of engineering was presented with various colors. However, he was colorblind. Of all the colors, he picked purple because it stood out more for him. It looked different, he said. Others should see it as well. IRWD worked with AWWA and made purple the standard for recycled water. Water and wastewater is listed as one of the 16 critical infrastructure. The short definition for critical infrastructure is that any destruction or disruption can put the nation, its economy, public safety, and health at risk. Most of you are very familiar with the term IT. OT is a term that is commonly used in the critical infrastructure and manufacturing. Essentially, the definition of OT is the use of hardware and software in real time to monitor and control physical devices and processes. OT is the umbrella term that covers Industrial Control System, SCADA, which stands for Supervisory, Control, and Data Acquisition. Some other commonly used terms are HMI, PLCs, and DCS. Today, I will focus more about SCADA and PLC. In a nutshell, a SCADA system will allow operators to remotely control and monitor the system in real time, program automated control, capture the data, and generate reports, optimize the process, alert the operators whenever there's a problem, and most importantly, protect the water quality in real time. In order to run a treatment plant, you need to have the ability to see what is going on, the health of the treatment plant, the status of the equipment, and have the ability to turn things on or off at your fingertips. It's like driving a car. Would you ever drive a car without monitoring the road? A similar analogy to cybersecurity is visibility. In order to protect, you need to have the ability to monitor the network with a product such as intrusion detection system, so that you know what is going on and if there's a hacker in the network. Each pin you see on the map is a station. We have over 160 stations. Most of the stations are required to talk to each other, get information from each other so that they know what to do. For example, a pump station that pumps water to a water tank that is located 2 miles apart. It needs to know if the tank is full so that it can turn the pump off before it overflows. If the tank water is low, then start the pump again. It isn't possible to staff operators at every station. The SCADA and PLC work together to automate workflow and reduce tedious work. Nowadays, we're lucky. We have Alexa and say, hey, turn the AC on when we're not even home. Doesn't technologies make life easier, so much more convenient? A programmable logic controller, think of it as a robot's brain. You take inputs from the sensor and perform action based on your logic. I'm sure you're all familiar with the if-then statement. For example, if the level is greater than this, turn the pump off. If the level is less than this, turn the pump on. Depending on the complexity, we can have thousands and thousands of logics in each treatment plant. All SCADA have a historian server that collects and stores data from compliance report generation. For example, min, max, average of the water quality, or any process data for the last 6 months, or the last 5 minutes, or whatever the period you specify. How many times did the equipment turn on or off? How many hours did the pump run so that we can change the oil? With machine learning and AI, we can take the SCADA to the next level for optimization. We can send some of this data to the cloud so that we can perform predictive maintenance calculation, or even process optimization. We can program the PLC to turn equipment off when electricity is expensive and turn equipment on when electricity is cheap. The next generation SCADA is to utilize that data from the historian, combine it with machine learning and AI and the PLC so that we can optimize costs. There are lots of exciting opportunities to combine IT and OT together for the next gen SCADA in the Industrial Revolution 4.0. Whenever something goes wrong, or the system detected water quality issue, operation will get an alert via text message, phone call, or email so that they can address the issue. A similar software that cybersecurity analysts rely on is a SIM, Security Information and Event Management System. Whenever the IDS, IPS, or antivirus detects some sort of malicious activity, you want that information to be forwarded to the SIM so that the analyst can get an alert and start an investigation. An inline turbidity meter is one of the instruments that measure water quality. It measures the cloudiness in water. A low value means that the water is clear. A high value means it is cloudy. So whenever the system detects a spike in turbidity, we want to stop the water from leaving the treatment plant and alert the operation to take action. There's a similar product in the cybersecurity toolset. It is called Intrusion Protection System. You can program it to monitor the network packet, and if it matches a certain signature that you determine it is bad, you want to block it from the network and alert the cybersecurity analyst. Here is a screenshot where operators adjust alarm threshold in the SCADA system, similar to what you would do in a SIEM. In this case, if the level in the basin exceeds a certain level, you want to get an alert. In a SIEM, maybe you want to adjust it such that after 10 fail log in, you get an alert. I hope I was able to convey what is a SCADA system by using some of the cybersecurity analogy and vocabulary. Again, I'm going to remind you, student out there, to keep an open and growth mindset, because this is how innovation occurs, and this is how we learn. You take the concept from OT or whatever you are learning right now and transform that concept into a different application for a different industry and take it to the next level, and you will have a whole new product. The ability to turn equipment on and off remotely with SCADA versus Alexa, monitor and control versus intrusion detection system and protection, alarm notification versus a SIEM, and historian data for optimization versus machine learning for big data optimization. We all know that water is the source of life, and when we look for life in the outer space, the first thing we look for is, does this planet have water? If you perform extreme outdoor activity, you will know how important water is. They say that people can survive up to 3 days without water. I don't ever recall going through a day without drinking anything that contains water. Please don't try this at home. I don't want to be responsible if something happened to you. However, there are some people who got really upset because Facebook was down for a couple of hours. If people were upset because Facebook was down for several hours, imagine what would happen if people can't flush the toilet or brush their teeth. We're so used to having water that when we turn the water faucet on, we expect to have water. What would happen to the economy and the impacts on us if there was a mass coordinated attack on several cities all at the same time? Here are some recent cybersecurity events that can be found in the news. The first 3 cases were ransomware, and their motive was most likely money. But what if the motive of the hacker isn't about money? What if their motive was to hurt people? Not all problems in life can be solved with money. The last case was an attempt to poison the water. The hacker tried to increase sodium hydroxide dose 100 times greater than normal. Sodium hydroxide is used to raise the pH level in water. Similar things happened in 2019. Instead of poisoning the water, the hacker shut down the disinfection system. A disinfection system is used to kill bacteria and viruses before the water leaves the treatment plant. A joint cybersecurity advisory that details the ongoing cyber threat to the U.S. water and wastewater sector was released by CSAF, FBI, EPA, and SSA 2 weeks ago. If you're interested to read more about it, I have included a link at the end of the presentation. Some of the operational technology equipment, software, or protocol were designed or built before the existence of Internet. They were never designed with any cybersecurity protection in mind. Most of OT are designed to last a very long time. It can be as long as 25 years, so there are still a lot of legacy devices in the OT environment. In addition to having no cybersecurity protection by design, it was also never intended to be connected to the Internet. So what happened when you start allowing remote access to the OT environment and connecting the network to the Internet? We put the OT network at risk. OT equipment is also very sensitive, so careful planning is required to install cybersecurity protection software or hardware. I have heard of cases where people were doing vulnerability scan on an OT network and accidentally knocked down a bunch of PLC and SCADA server. If you look at the operator's control room in the 80s, compare that to the modern one. We essentially digitized the entire control room. As a result of COVID, the common trend is to decentralize the control room and work remotely. More and more treatment plants are starting to allow remote access to the SCADA environment. My biggest fear is that some IT network administrator allow remote access without understanding or provisioning the proper cybersecurity protection for the legacy OT equipment and network. Most of you have heard of the CIA Triad. Essentially, if you have to protect all three, confidentiality, integrity, and availability, but you have limited resources, which one would you protect more? That really depends on the business need. In most IT environments, confidentiality is ranked very high because that is where all the R&D, PCI, PII, and HIPAA information are stored. While in the OT environment, safety is number one. Hence, the ability to control equipment to protect our staff, public safety, and health is ranked at the top. Availability is second because downtime can be extremely expensive and disruptive. Extended downtime can also impact public safety in some extreme scenario. For example, what would happen to our cities if we don't have water for 1 week? In the water sector, within the OT environment, confidentiality is ranked lower because there is very little confidential information stored in the OT environment other than configuration file. The original Modbus communication protocol was developed in the late 70s and the TCP/IP version of it in '83. During those times, bandwidth was a concern. They tried to come up with the most optimal way to send and receive data, and cybersecurity wasn't a concern because it was usually a direct connect or locally within an isolated treatment plant. Think of the treatment plant as a castle. It is protected by the physical fence. It doesn't have any connectivity to the internet because internet wasn't even publicly available until '93. The word cybersecurity didn't even exist then, so why would they care about authentication in the '80s? So the only security required is physical security, which is a fence. Modbus is like an open door policy. If you are in the local area network, you can read, write to any PLC. The concept of being able to control the treatment plant remotely was just a dream back then in the '80s. The word cybersecurity was first used many years after the Modbus protocol was invented. I purposely redacted a word because I thought it was inappropriate in a school environment, so viewer discretion is advised. It is like my kid, the moment I tell them not to touch anything, they touch it. I bet you here, someone already Googled it. Here's the perfect storm. You have a product that is designed to be very stable and last a very long time. So there is very little incentive or return on investment to replace it. Some of the OT protocol were utilized before cybersecurity even exists, and newer products are required to support the legacy Modbus protocol due to compatibility reasons. With the rapid advancement of IT, we have remote access as a dream come true now, something that wasn't even available in the '80s. People can control the treatment plant remotely, but in order to make that dream come true, IT network administrators are required to tap into this castle that was never meant to be connected to the internet. This isolated air-gapped network is no longer a true air-gapped network anymore. I usually compare OT to a turtle, slow and stable and lasts forever. In the IT world, to stay in business and remain competitive, new features are released very often to improve productivity. For example, people replace their iPhone every few years. Server can run much faster for the same amount of electricity each generation. Software might get more productivity and security features, so the life cycle is much more shorter if compared to OT. At the same time, patches are released each Tuesday to address security issues. It is very often to see computer or server crashes after patches are applied. In the OT environment, safety and availability is ranked at the top, while new features is usually ranked lower. The number of cybersecurity incidences reported to DHS from the water sector went from 14 to 25 cases in 2015 and is the fourth largest compared to other sectors. There could have been more unreported cases. The attacks are becoming more and more sophisticated, where hackers can destroy equipment that is not connected to the internet. For example, nets that destroy the Iranian nuclear centrifuge and black energy that took down the Ukrainian power grid. Imagine what the attack vector is like when the OT networks are connected to the internet. The fourth generation of industrial revolution is occurring right now. Machine and machine are talking directly through the internet. Smart sensors are installed to collect water quality and usage. Data are no longer sitting inside a silo within the castle. Air-gapped or isolated network is no longer truly a 100% air-gapped network. The front gate of the castle is open. Processed data are being sent to the cloud for AI to analyze. Most of you are familiar with the term IoT for household usage, such as Alexa, Nest, and some of you have heard of what happened to the Ring security camera hack in 2019. What happened if someone hacked Nest and decided to turn on all the AC across the country all at once in the middle of the night? What would happen to our power grid? I'm not trying to scare you. I'm trying to tell you we have to make sure it is secure. IoT that is being used in the industrial space is called IIoT, the fourth generation of industrial revolution. That is where IT and OT join forces together and take it to the next level. As the IT and OT converges, it opens up new possibility for OT to increase productivity. But cybersecurity vulnerability can be managed if we have the right staff that understand both IT and OT. One of my favorite quotes from Albert Einstein, which motivates me to move forward, is, "In the middle of difficulty lies opportunity." Think of difficulty, failure, and challenges as an opportunity to grow stronger. It is also an opportunity to come up with new product or solution to address the problem. It is important to have an open and growth mindset in the cybersecurity industry. Hacker will always find a new way to hack. Defender will always come up with a new way to defend. Things are constantly changing. Cybersecurity in the water sector is not as mature as the power industry yet. In the power industry, they have to meet NERC standard. Water doesn't have a cybersecurity standard that it must meet yet, but I wouldn't be surprised if there is one in several years from now. This simply means there are lots of opportunity to grow, to harden the cybersecurity posture within the water sector. This is one of the PowerPoint slides that I used to get cybersecurity staff and funding. I was holding a real onion in my presentation with upper management and said, "This is how I make a hacker cry." They look at me with interest and a smile. I explain each layer of cybersecurity protection is like an onion layer. In order for a hacker to get to the Bitcoin, they will have to peel through many layers of onion. So if each layer fails, there's also another layer after that. The goal is to have so many layers that is feasible so that you can slow the hacker down. Make the hacker cry as they peel the onion, and hopefully they trip over a wire and you detect them. There isn't a single tool that can protect everything. If people think that firewall and antivirus is sufficient, maybe 20 years ago, but nowadays you will require more than that. You will need layers of cybersecurity protection. Another commonly used term is called defense in depth. So essentially, they agreed to give me 2 full-time farmers to grow onion. Two full-time cybersecurity analysts to grow cybersecurity onion. All right, we have a pop quiz. Can anyone guess what is the name of this movie before the video ends?
Ogres are like onions.
They stink?
Yes. No.
Oh, they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white hairs.
No. Layers. Onions have layers. Ogres have layers. Onions have layers. You get it. We both have layers.
Oh, you both have layers. Oh. You know, not everybody like onions.
So remember, onion have layers, cybersecurity have layers. Sorry, I know that was a lot of information that I packed down in this PowerPoint. If you forget, that's okay, but please, please don't forget these two codes. See difficulty as opportunity. And you can apply that to anything in life. And of course, onions have layers, cybersecurity have layers. I wish you all have a successful career path.